Let's see this question. This question is given in GATE 2014 in the subject Signals and Systems. I'll read the question. Let h of t denote the impulse response of a causal system with transfer function 1 by s plus 1. Consider the following three statements: S1, S2 and S3. S1, the system is stable. S2, h of t by h of t plus 1 by h of t is independent of t for t greater than 0. Then S3, a non-causal system with the same transfer function 1 by s plus 1 is also stable. And whether he is asking that only S1 and S2 are true, S2 and S3 are true, S1 and S3 are true, and all the three are true. Now we will see each statements individually. Later we will find whether which one is true and which one is false. We will go with the first statement. Okay, first take the given transfer function. H of s equal to 1 by s plus 1. Now we will find h of t. H of t equal to, if you apply inverse Laplace transform to this, it will become e power minus t u of t. Now if you observe here, this is positive for all the things. U of t is positive in the time axis. So if you draw the ROC, that is region of convergence, it will become real part of s is greater than minus 1. If we draw the graph for this, it will be like this. Okay, this is j omega, this is minus 1, and if you draw the graph, it will be like this. It will be greater than minus 1, and this is s plane. So if you observe, this is towards right side of the minus 1, ROC, which covers JW, j omega. So it implies this system is stable. System is stable because ROC covers j omega. So we can say that system is stable. So S1 is true. S1 is true. Now coming to this second statement, given h of t plus 1 by h of t is independent for t greater than 0. We will check this. Now after this will become e power minus t plus 1 u of t plus 1 by e power minus t u of t. If you expand this, e power minus t into e power minus 1 into u of t plus 1 by e power minus t u of t. E power minus t gets cancelled. This will become u of t plus 1 by u of t into e. Now here u of t plus 1 is equal to 1 for t greater than minus 1, u of t equal to 1 for t greater than 0. You take the most which covers both, like t greater than 0. If you take t greater than 0, it covers both. So t greater than 0, it implies both u of t plus 1 and u of t become 1. This is equal to 1 by e. Now you can see the end term. This is independent of t. Independent of t. So which states that S2 is also true. S2 is also true. Now let us check the third statement. Okay, a non-causal system with the same transfer function is stable. Now if you take the same transfer function 1 by s plus 1, for this, if system is non-causal, then you can write h of t as e power minus t u of minus t. If you observe this, u of minus t, this is going to the negative axis. If you draw ROC, real part of s is less than minus 1. If you draw the diagram with respect to s plane, this will be minus 1. This will be minus 1 axis. This is j omega. The diagram looks like this. this will go to the left of minus 1, which does not cover j omega. Here j omega not covered by ROC. So we can say that system is non-causal. We have taken non-causal system, so system is not stable. But in this statement they have given that it is stable, so we can say that S3 is false. Okay, S3 is false because ROC is not covering j omega, it is towards left of the minus 1. Now for this system, for this S1, if you need to check in terms of equation, you can try like this: integral minus infinity infinity mod of h of t is less than infinity. If this is true, then the system is stable. You can also check in this form. Okay, in this way S1 is true, S2 is true, S3 is false. You can check in the options, only S1 and S2 is true. So A is the correct answer. Okay, thank you.